basically at random points, and it's picking a random piece of fruit each time. They're falling, which doesn't help us too much, especially if we're doing a click the fruit type game. I mean, you've got to have some pretty good reflexes. And yeah, basically it's just picking the fruit and spawning. Now we've got a couple of issues with this. And we're going to solve these together. One is the fact that they're spawning at the bottom, they're dropping. That's not an issue. That's what we told it to do, so that's what it's supposed to do. What we want to do is we want it to arc through the air and apply a particular force. So for example, one of these spawn points, so spawn point 1, which is on the far left-hand side, is basically angled at this particular point. Now when an object is created there, it's going to adopt that same rotation like we set in the code earlier on. And basically what you want it to do is it set that rotation and then apply a force upwards and round. So that's one thing that we're going to overcome. Another thing that we're going to overcome is clicking them. So we want to write some code that basically allows us, when we click oranges, get points of oranges. Another problem is we want to display how many points the player has. But that's quite easy to do. Another problem that we have is the fruit isn't leaving the scene. So for example, if I zoom out, we've got one massive fruit, like helix or something, or it's like some form of strand of DNA of fruit, I guess. I don't know. Terrible. Yeah, it's all terrible jokes. It's all downhill from here. Cool. So obviously we need to deal with that. We need to we're creating these things and bringing them into the scene, but we also need to get rid of them. So we're going to put timer on the fruit, almost like a death timer, to say after a certain amount of seconds, remove it from the scene. So we're not trying to calculate thousands of fruit and all their physics and all their rigid bodies and stuff. Another thing is audio, but that's not really an issue. Another thing is spawn delay. So we've got a whole bunch of bits and pieces. So I'm going to work through that now. So first thing we're going to do is spawn delay. So we currently have a set amount of time between each fruit being created, which we've picked in the editor. So in the editor we've basically said every 0.3 seconds create a piece of fruit. Now we could leave that, ship the game, be happy with that. It's kind of a bit boring because it's kind of like the set amount every single time. Whereas if you play a game, you don't want it to have some sort of structure. You want perhaps a clump of enemies or a clump of fruit being created and things like that, because then it's more fun, it's unpredictable. Now I always find unpredictable elements in games, not rigid ones, are sort of the more fun things to play around with, because you're not quite sure what's coming yet. I know fruit's going to be coming, but I don't know how it's going to be coming or what sort of force it's going to be coming in. So what we're going to do now is we're going to create two variables. And this one's going to be called min time. And another one, this is called max time. So we're going to use the Unity editor. We're going to use the Unity editor to basically set what the minimum possible time could be between a delay, what the maximum possible time can be between a delay, then use that. And it's going to be calculated randomly each time. So we're going to basically do what we've just done, but yeah, for min time and max time. So I've added those two variables there. So I'm going to scroll down. Now, before we use the spawn delay in invoke of spawn fruit, I'm going to write spawn delay equals random.range min time max time. So basically, spawn delay is now going to be a number between the minimum set time and the maximum set time. Now, what those time values can be is completely up to you. You could have them spawn very quickly, or perhaps like a long time between them to build tension. I don't know, it'd be quite a boring game. It's only fruit. But yeah, so basically what I want you to do now is, now that we have the min time value and the max time value, so has everyone got that code down? Cool. What we can do now is we can basically just set the spawn delay to be 0, because we're overwriting it anyway, and we're going to set the min time to be something in max time. So I'm going to set the minimum time to be perhaps 0.3, and the maximum time to be perhaps 0.7. Now that may be too quick, or that may be too slow. I don't know yet. The only way I'll be able to tell is basically then by running the game and seeing what it is. But the great thing about Unity is the fact that if I say, for example, okay, max time now actually needs to be 0. I don't know, or 1.4, for example, I need to extend that gap between those points. Perhaps, you know, I don't need to go into the code and basically tweak these things. Because they're all exposed in the editor, I can then go in and just tweak them here. I could give them to my 6-year-old cousin and say, change these values and play around with them. She'll probably be able to do it without having to look at code, which is pretty useful for people who aren't double coders and get scared by code and say it looks like the Matrix. Does anyone else have that? Like, they get someone looks at their code and says it looks like the Matrix, or you're writing the Matrix and stuff, and it's like
it doesn't, because you can read it actually.
yeah, this is true. I'm sure my girlfriend looks at this and gets a bit scared. Yeah. Cool. So now what we're going to do is we're going to see how this works. So what you're noticing is it's spawning. What you can see here is the spawn delay is also changing. So in the editor, that variable, that particular float is actually changed. So you can see it's 0.5, 0.3. As it's a float, it could be anywhere between those numbers. I think that's fine for the moment. I guess we're going to have to add a force and then see how it looks in the end, but I'm pretty happy with that. So has everyone got that working? That you can see the little variable updating in the editor. Awesome. So let's add some behavior. So now that we have a script that basically spawns all the fruit, we're now going to make a script and attach it to all the fruit and basically say, this is the behavior for all the fruit. So I'm going to go to create C# script, and I'm going to call this fruit behavior. This is going to be a very, very short script, but it's basically going to it's going to go into each of the bits of fruit, go to the rigid body and say, apply a force in this direction, rotate it, give it, some form of timer to say it removes itself after a set amount of time, things like that. So what we're going to do now is take fruit behavior. Now we want to use this class for all these pieces of prefabs. So what we're going to do is drag and drop this fruit behavior script onto each of the prefabs. I know that's kind of a little long way to do it, but there's no way to select multiple objects and then drag and drop onto all of them. There may be. So if I... Okay, there is as well. My bad. Okay, so if you select all of the fruit, all the prefabs, what you can do is, by selecting them all, what you'll notice is that the preview will show all the 6 objects that you selected. What?
No, it makes sense.
And then go to add component. It will basically have a list of components. Go to scripts, and then underneath here it's got what we want. So in this case, fruit behavior, and now we've attached fruit behavior to each of the prefabs. So each of these prefabs is basically going to use the same script. Because we only write one. We don't want to write a lemon class, lemon half class. If they're all doing the same thing, we want to do that. We could write specifics. So we could say, for example, the lime, when it flies through the air, has a green trail or green juice flats or something like that, as opposed to the yellow one. In that case, we'd have to write more specific classes. But in this case, we're going to use one for all.
What you're attached to. So could you say if my prefab is lemon, then do this in your script? So that you're still in the same script?
From which script? Oh, inside the script. Yeah. So you could basically say
what am I, and then do the yellow or the green or whatever.
yeah. So you could say if GameObject.name is lemon, then do a particular thing based on the lemon. Yeah. You could do that. We're going to be doing that in a second when we start clicking them, so you can only destroy lemons or destroy limes. It changes. Cool. So what we're going to do is we're going to open up fruit behavior, and we're going to do some stuff with fruit behavior. So what we want to do is we want to have a couple of forces. So I'm going to make these private. So currently we've made all of our variables public. So that means that if they're edited in the inspector, it's going to overwrite whatever you write in the code. So if I write in the code, this is, for example, a force of 50, and then in the public inspector I say it's actually a force of 500, it's going to overwrite that one that's already written. It does that. So what we're going to do is we're going to use private instead for this, just to show that. So we're going to make an up force of 650. So we're going to apply an up force of 650. And we're going to do a private float of a sideways force of 200. So the up force is fairly self-explanatory. Sideways force is basically going to add a torque, so it's going to spin. So as opposed to very uniform things like that, it's basically going to spin in mid-air and then clash, and it's going to be quite cool. It's not going to be so rigid. The feel of the game is going to feel right. So what we want to do is we want to access the rigid body component. So each of our pieces of fruit have a rigid body on. So what you can do is, like when we did renderer.material.color equals this, we can do a similar thing with rigid body. We can access the rigid body and say, go to the rigid body, add a force, or change the mass, or add a velocity, or get the velocity of this particular thing. And we're going to do that as well. So if I go into here, and I go into void start, we want to add a force. So we don't want to add a force in update, because every frame it's going to be adding a force. It's kind of like if I wanted to push someone into a puddle, I'm just going to push him once. I don't want to constantly push him because I'm going to follow along with him. So what I want to do is in start, as soon as the object becomes live, I want to add a force, give it a bit of a kick in a particular direction. And in this case, we're going to write rigid body, add force, and then in here we have to give it 2 parameters. The first parameter, well, it's 1 parameter, but it's made up of 2 things. So the first one is direction. So which way we're going to do it. Is it going to go up, left, right, at a particular angle? We have to multiply that direction by like a force value. So that would be a float or an integer or something like that. So in this case, what we want it to do is we're going to use transform.up. So we're going to apply it upwards, but as the object's slightly rotated, it's going to be at an angle. We're going to multiply it by the up force. So if the object is like this, it's then going to apply it transform.up, the object's up. If you use vector3.up, it will always be up. So vector3 is kind of like the global up, whereas using a transform is like the local up, for example. So whichever way it's slightly rotated. We're going to do a bit of that tomorrow when we have a spaceship flying around. So all excited for that. It's cool. Cool. So now that we have that, and we've written that code, as this class is attached to all the fruit are going to don on all of the things that happen in this script. So then if we go into our game and then run it, what should happen is we should have fruit now flying into the center of the screen. They're all very uniform because we haven't spun them yet. But yeah. Has anyone not got that? Awesome. So we have lots and lots of fruits flying around, doing things. Very fun. So I'm not happy with that still because they're all very uniform. They're all very kind of, even though they're going through the air and colliding and things like that, they're all very static. So what I want to do is I want them to randomly sort of have a little bit of a kick or a spin at the start. So they're all already tumbling through the air. They're not so flat and boring. So what we want to do is we want to go to fruit behavior, and we're going to write some code. So this is the thing that basically kicks off the fruit. So what we want to do is, as well as adding a little force, we also want to spin it a particular way. So in this case, we're going to do rigidbody.add add torque, and that torque we're going to use, just pick a particular direction. So you could do vector3.left, vector3.up, vector3.right, vector3.down, basically whichever way you want it to spin, then multiply that by sideways force. Now you could change these values if you want. So if you think 650 is a bit too low, you can obviously change that up, like 700, 800, whatever it may be. Sideways force, you can change that there. But as these are private values, you can only sort of change them in the code. So you can use public stuff or inspector stuff, or you can do everything private all in the code. So yeah.
But what if you multiply with vector 3? Is that a variable or something?
Pardon?
What is vector 3.left?
Okay, so vector 3 is the x, y, z coordinates, and dot left is basically saying which direction those coordinates you want to go. So vector 3.up is straight up, vector 3.down is straight down, vector 3.left is x, from your direction x, and
But
then
they're not the coordinates of the object, they are just abstract.
yeah, they're just a particular direction, either up, down, left, right, forward, or back. Yeah. Now, I could go into there and give it a particular rotation, but in this case, I just want it to spin left or spin up or spin right. You could go way more in depth and basically randomly calculate a different spin direction each object and stuff like that. But that's kind of like going into the meter bit. So now, what should happen is they now spin. They do like little flips and stuff. So already that's kind of a bit more interesting and a bit more visually nice, I guess. currently they're spinning upwards, so what if I made them spin like that? Right, so now they're spinning sideways. Cool, so has everyone got fruit spinning or not spinning? Okay. Cool, so now that we have fruit colliding and things like that, what we want to do now is we now want to remove them. So what I'm going to do is I'm going to set up another variable. So this is going to be called kill timer. So this is going to be a float. And kill timer is how many seconds it's going to be before the fruit removes itself. Because currently the fruit is being added, but it's not being taken away from the scene. We kind of need to destroy it and get rid of it and almost like throw it in the bin and not use it again. So with kill timer, we're basically going to state after... Trouble is doing something like 0.1 second, after 0.1 second and being in the end, they're just going to be removed in front of the player. So you need to pick a time where they're going to fall out of view of the player, but they are going to remove eventually. So let's do perhaps 3.0 F. Or 3, whichever. So let's do 3. Then what we're going to do now is, from start, we're going to set off destroy, game object, kill timer. So what destroy does, so if I just write out standard destroy, so what destroy does is the opposite instantiate. So whereas instantiate basically says, hang on, I'm just writing this mock code. So whereas instantiate basically brings this object into the world, destroy kind of like takes it out of the world and scraps it and basically gets rid of it. So just writing destroy game object will remove this particular object. Also, you can do pointers. I could say destroy, for example, explosion or something like that. It would then destroy an explosion which has been stored earlier on or found earlier on and things like that. So what we're doing on start is we're saying destroy the game object, but after a set amount of seconds. So in this case, 3 seconds, we're saying remove the object. So what we should be able to see now is when we go back into Unity, the fruit should remove itself, maybe. Yeah, it is. So you notice that after 3 seconds of it being in the game world, it's kind of like... destroying itself. So we don't have tons of fruit. And you'll notice our hierarchy is a lot cleaner now, because it's actually removing. We're not creating hundreds and hundreds and hundreds and hundreds of fruit. We're actually removing them eventually, which is pretty useful, actually. Has everyone got something similar to that? Or... So you might want to look at the scene view if you want to see it actually sort of doing this removing process. Awesome. Cool. Yes, I was originally going to do that, but the trouble I had when I was doing like it beforehand was some of the fruit were hitting the other fruit above the camera view. So basically I was doing a thing, if it's not being rendered by the camera anymore, destroy it and remove it, which would have been useful. But sometimes a fruit comes up, another one hits it and it goes above the camera, and you'd expect it to come down, but it was detecting it wasn't rendered by the camera. I'm sure there's a way to say, if it's not being rendered by the camera, work out if it's lower than the camera and things like that. But I found this way was just easier to write up. Yeah, so you can do renderer.is enabled, or renderer.is visible. Yeah. Yeah, so you can do that to say when it's out of view of the camera, do this. Yeah. Cool. So, yeah, we've now got fruit tumbling. So we solved a couple of the issues. We've added spin. We've added some form of death thing to it. We're removing the fruit. But currently there's no interaction. It's not like we're clicking a button and basically making a piece of fruit. What we want to do is we want to be able to click the fruit and basically say, click the lemon and get a point, click the lime and lose a point. So we're going to do something like that. But we need to go into the fruit spawn actually, yeah, let's do something else. So we need to write another script, and this is going to be onto our camera. So whereas before all of our important scripts, So let's go to here and go. Okay, so this one's called click control. What we want to do with click control is we want to attach that. Oop, it's doing something. Yeah. No blue screens here. So with click control, we want to open that up and we want to do a couple of bits and pieces. So the first thing that we want to do with click control is we need to set up a couple of private things. So we're going to use a raycast. So do you guys know what a raycast is? Or okay, that's cool. So a raycast is a method of sending out an invisible line in a particular direction and then returning some form of thing that it hits. So it's the simplest way that you can think about it is if I pointed in a direction, I return information of what I pointed at. So if I point at the candle, basically I'm returning the fact that I pointed at the candle, I'm pointing at where that location of that candle is, that it's hot, what it looks like, things like that. If I then point at that wooden beam, I know it's at that particular position, what it looks like, so on and so forth. Basically, yeah, that's generally how that works. And you use raycasts from the camera in Unity to basically detect what you're clicking or what you're tapping at. So in The Sims, so I'm talking about Sims again, basically if you click on an object from The Sims, so say like you selected your sim, then you click on a bookshelf, what that's going to do is it's going to send a raycast in the direction of where you've clicked. It's going to get the bookshelf, return back saying, oh, you've clicked on the bookshelf, and then it's going to do something particular. So for example, go read a book or go do a thing. So what we're going to do is we're going to send a raycast out from the camera of wherever we click in that particular direction, so almost like shooting lasers. When it hits a lemon or hits a lime and things like that, it's then going to return information such as what we clicked, get points, don't get points, all this information in there. So what we need to do first is we need to set up a variable called ray, which is going to handle the direction of the ray, and it's going to handle basically how long the ray is, which direction it's going in, things like that. And we're going to set up a variable called raycast hit. So that's basically all the hit information returned back to the camera and says, right, we've hit something, what are we going to do with that thing? What is it? Narrow it down for me. Cool. So we can do void update. And inside update, we want to do if input.get button down, and you do mouse 0. Oh, actually, get key down. Sorry, there's a couple of ways. What we're going to do is we're basically going to send out a line to a particular location. So we're going to say ray equals camera.main.screen point to. I'll write all this out and then I'll basically explain what it's doing. I think that's right. Yeah, that's right. Cool. So what that's doing now is we don't want it to be constantly getting what we're pointing at. We don't want it to be constantly shooting a ray out to wherever our mouse is, because that's going to be doing extra stuff that we don't need. We don't need to do some form of highlight system. We want to basically say, when we click, get the location of where we clicked on the screen and send a line out and basically return what you've clicked on. So this ray is basically saying from the camera, because when you do a raycast from the camera, you have to say which camera you're pointing it from. So in this case, the main camera, the only one we've got, screen point to ray. So screen point is basically saying, within this view, if I click there, it's going to go to the camera. It's basically going to click. If you think of that camera, it's going to say, all right, you've clicked in the top right-hand corner. It's then going to go from the camera as the origin point and send a line up to that top point corner. So that big square there, where it's projecting onto, is basically your canvas that you're shooting the line out onto. Then what you want to do is pass in what you're clicking. So in this case, input.mouse position. So it's going to get where the mouse is and fire line to that position. Now what we'll probably do tomorrow is we'll probably do touch position. So we've got input.mouse position if you're running on here, whereas you can say, however, if you're on a touchscreen thing, you can do input.touch position and basically get where you're touching instead. So you can use either a mouse or your fingers and stuff like that. So we've generated that, which is cool. Next thing we need to do is we need an if statement. So we need to return an if statement to see if it actually hits something. In this case, if physics.raycast do something. So if physics.raycast, and you pass in basically the ray, so which direction it is, how long is it, where the origin is, which direction it is, and things like that. We then output that information to raycast hit. We then say how long the ray is going to be. So if I'm making like a third-person, like Tomb Raider, probably the best example. If I have the option to pick up that table with the jackets over there, I don't want to stand over here, click on it from here, and then move it with really long arms over like that, because the raycast will basically go out, return it, and then I'm moving that. What I want to do is when I click to say grab table, I want it to go out, for example, as long as my arms are. So for example, a unit of 2, like 2 feet or something like that. Then if it returns that I'm within arm's length, then I can move it and stuff like that. So in this case, we can sort of go a bit overboard and say 100. So we can send out a right line. It's basically just can keep traveling for 100 units, and when it gets to that point, it hasn't hit anything. It's then just going to like cut off and basically say stop. Don't bother returning anything back. But I know that our camera is fairly close to where the fruit's spawning, so we don't have to worry about that too much. We can do 100. But more specific stuff, you'll probably say within a unit of 2 or things like that. So let's go back into Unity. Cool. What we can check is in the console, we haven't really got any bugs, no errors and things like that. So we've got something like that. Now that won't return anything yet. What we now need to do is we need to do something when you click something. So in this case, what should we do to the fruit? Let's destroy them. So what we're going to do now is we're going to say, if we click the mouse, and it sends out the ray, and it hits something, delete that particular thing. So in this case, it's going to delete any fruit that we click on, no matter what it is. And then we'll narrow it down to like specifically a lemon, you get points for it, as opposed to, you know, like a lime or something like that. So yeah, we're going to send a line out and destroy the fruit. So we're going to do destroy, and then we're passing in what we're using. So in this case, hit, so that data, the collider, the hit, and the game object, that collider.
Question. If we have some object in front of the fruit that it's transparent, for instance, and I want to destroy behind that object, how can we do it?
Okay, cool. So every object, you have a system called layers. So this is useful if you have like a heads-up display or you don't want to shoot at your own gun and things like that. So what I can do is I can say if I had a big texture, so I'm going to take this cube, for example, that's positioned here. It's set all onto the default layer. But if I go into the default layer, I can say ignore raycast. So if you had some form of, perhaps like a waterfall in front, you can tell to the waterfall to ignore the raycast and it'll pass through. Also, a raycast will only collide with an object that has a collider. So if it's just a mesh renderer and it doesn't have a collider, it won't detect it's hit anything because it's got nothing to return that it's hit. Yeah, it's just going to pass right through it. So yeah, ignore raycast is quite useful. So anytime I do any sort of GUI or like first-person shoot have a gun, I just tell them all to ignore the raycast so I can't like, you know, shoot my health bar or something weird like that. Yeah. Cool. So now that we've written that code, we basically need to apply it onto an object. So normally we'd apply it onto the manager because that's got all the important stuff. We're not going to do it this time. We're going to apply it to the camera because we're going to send the raycast out from the camera. We're going to say the raycast out from this origin point. So I'm going to drag and drop click control onto the camera. And what you'll notice is click control has popped in. The private variables haven't been shown. So what you can notice now is after touching to the camera, we can now click the fruit. Or not. Oh, mouse 0 is unknown. Okay. I think it's mouse space 0. Yes. Pardon?
There's an enum as
Typo. I accidentally put like no space in between there. My bad. Now it's space 0. Cool. So we're deleting lots of fruits, which is quite cool. I've got a little. So what we're going to do now is we're going to narrow it down. Actually, let's do some audio stuff. So what we're going to do with the audio is we're basically going to emit an audio clip whenever we click fruit and it splats it. So what we need to do is we need to go into here and we need to write public. So we're going to drag and drop this particular audio clip in. Audio clip, fruit, splat, SFX. And we're going to play that every time we click a fruit and it's destroyed, which is cool. So before we do that, we need to have a look at audio sources and audio listeners. So for any audio source, you need an audio listener. So that audio listener is basically what is going to receive the audio in. So for example, our ears are audio listeners, listening in to when people talk or any sort of audio. You guys have ears, you know how it works. So the main camera, the main camera default has an audio listener on there. And apart from making a multiplayer game, Unity will tell you off if you have more than one audio listener. Basically, you should only have one, and I'd argue that 99.9% of the time you're going to have it from the camera, because that's from the player's perspective that it's going to be receiving the audio sources from. So the audio listener is there, and that's going to be what's listening out for the audio in the 3D space and the 2D space. So the other thing that you need is an audio source. So what we can do is if we go onto the manager, we can go to component, audio source. Now you have some other things like audio reverb, which is like for caves, like echoing sounds and things like that, and low pass filters and things. But what we're going to do is we're going to attach to the manager an audio source, and basically we're emitting audio from this particular point, this manager, and we'll be able to drag and drop this here. So I normally use audio sources in this sense for like 2D sounds and background music that's going to play. So if I go into my audio file folder, we have fruit splat, so we have which we want to play whenever we, click some fruit. And we also have this background music. So now, whenever audio is brought into Unity, the import settings always set it to 3D by default. You only have to click it to change it to 2D. What we want to do is we want to say the background music playing is 2D, so we don't have to worry about where it is in the game. We don't have to worry about that the object that's got this audio source playing is like a million miles away and we can't hear it, and we think we've bugged it or the audio doesn't work. So what we need to do is we need to toggle off 3D sounds and click apply. What it'll do is it'll go through and it'll convert the 3D sound to a 2D sound, and basically it sounds a lot better if it's a 2D sound. It basically doesn't have to work out where it is in relation to the listener, it just automatically overlays on the top of it in the background. So the preview sounds the same, but in-game it'll sound awesome. So if we now go back to our manager, we have our audio source being emitted from here. What we want to do is we want to drag and drop this Temple of Ruth clip onto the background. And what onto the audio source? And what you'll notice is it also says this is a 2D sound. It's telling you what it's going to be. If it's a 3D sound, it will say this is a 3D sound, it's fairly self-explanatory. And we have lots of other things that we can toggle on and off. So we can mute, bypass effects, reverb zones, so we don't want it to echo. We want it to loop, and we want it to play on awake. We want it to start from playing. We can also set, if we have got lots of sounds all playing, we can also set the priority. So we could say the background music takes lower priority down, for example, sound effects in the game or something like that. Like Half-Life 2 has very, very subtle background music that you don't really hear. It takes a priority over all the other sound effects of things actually happening as opposed to big blaring music. I love Half-Life, it's a great game. So yeah, we have our 2D sound playing. So now if we then run our game, we've got this 2D, I'm rubbish.
No, we don't play the.
You don't want to play the sound?
We didn't put actually code that we should play the sound when we destroy it.
Oh, I'm talking about the background music playing. We haven't scripted the other bit.
So once you put that sound of the audio to the manager,
because it's a 2D sound, it doesn't matter where it is in the game. And I like to put all the audio sources and things on the manager, like all the background music and things, because it's those are all important stuff. And then I like to put all the important stuff in the manager.
I'm not sure.
Because it's a 2D sound, it doesn't matter where it is. 3D it does matter, yeah. So now we've got lots of Temple of Roots. Yep, whatever you want really. You can just load in. Pardon? I don't know. Maybe? I'd have to have a list. Probably. I don't know. I'll find out. I know it'll take like all the standard stuff people would probably have, like MP3 or OGS or whatever. Sweet, so we've got our background music. Now what we want to do is we want to play some audio when we click on the fruit. So what we want to do is we want to attach another audio source. So we have one audio source for 2D sound on the manager, because the manager is basically holding all the important stuff, so in this case background music. Now what we want to do in our code is we want to reference the audio source on the camera, which has this script on, and say audio source dot this play this sound through this particular source point. It's like if we were applying force to an object with rigid body, the object has to have a rigid body. We want to play audio through this script on the camera, so the camera needs an audio source. Basically, it needs to have that thing that we're referencing. So we have an audio source here for the 2D sound, but on the camera, we want to go component, audio, audio source, but we're going to leave that blank, and we're going to turn off play on awake. So we don't want this audio to play, we're going to leave it blank. We're just going to use this as kind of like an output for the script. So when you're writing the script, play this audio through this audio source, it just routes it through here.
So for each audio we want to play, we need an audio source. So for example, we want to play two sounds at the same time.
You need like an audio source on the object that's emitting that sound. So if you've got a script on an object to say play a sound every 5 seconds, you need an audio source on that object to output that audio, basically. Cool. So we've now got two audio sources. One which is just playing, which we've set up in the editor and drag and drop. The other one's just going to be almost like a open casket, and we're just going to pass in on each of the individual fruits.
So the fruit is responsible to trigger the
Yeah, sure. We could do that. However, this is the script that's detecting. This is the well, no, actually, because what's happening is that the fruit is being destroyed, and it's an audio source on the object that's just been removed. So you're trying to play audio on something that's destroyed. It's like if you were playing music out of a stereo, and I smash up your stereo, it's not going to play music anymore.
for the 3D sound to get it right, it would be better.
Possibly, but what you can do now is solve your problem.
Okay, thank you.
Cool. So what we're going to do now is we're going to play some audio. So we're going to say audio source. So we're going to use that audio source that we've played. Play clip at points. Then inside the play clip at point method, we're going to pass in two things. We're going to pass in what audio we want, where we want to play it. So we could have 6 audio sources on all of our fruits, all emitting sound, and then you have problems with them being destroyed and stuff. However, we're controlling it all from this point. Now we have this variable controlling all the hit data for where it's hitting stuff. So we can just pass in hit.point. So now it's going to play an audio source through this audio point, but from this particular location in the game. Yeah. So now what you should be able to have is when you click fruit in the top right hand corner, it will sound like it's coming from that corner. If you click fruit in the top left hand corner, it sounds like it's coming from the top left hand corner and stuff. Yeah, so now that we have that all set up, we need to go to our script. We've got fruit splat SFX, and it's waiting for fruit splat. We drag and drop it in that little slot, and then we play it, and then we should be able to hear some audio, maybe.
Creating it.
So one thing you might want to do is increase the priority of that audio source, because currently it's at the same level as the 2D background sound, they're kind of overlaying. So if you increase the priority of the fruit spat sound, you might be able to...
The click control was attached to the camera.
Oh, okay, sorry. So you have a bit of audio now. So yeah, 2D you can just stick the audio source wherever. 3D you have to basically emit it from a point and tell it where it's going to emit. I think you can even see the audio source emitting it, maybe. Awesome. So if we all got splats and sounds and things, right? Pretty cool. So what we're going to do now is narrow it down. So, or explosions. Which one do you guys want first? Narrow down what we're clicking or explosions? I knew everyone would say explosions. Explosions are cool. So what we're going to do now is, rather than we just click it and we can just say destroy, get rid of it, thing, we could do a couple of things. What we could do is we could, for example, split the fruit up. We could play an animation of it squashing. I don't know, there's lots of different things. One thing that you can do is remove the fruit and put an explosion in its place. Make it go boom, yeah, exactly. But it will still go because I haven't got an explosion sound effect.
Sorry, since you pulled out the random fruit out of your eight, is there any way to find out which one of random fruit was?
Like what? One we've clicked?
Or what index it was?
Index.
Or what type of object it was? Was it lemon or?
Yeah, we're going to do that after the explosion stuff. We're basically going to find out if we clicked a lemon, and if we did click a lemon and destroy it and get points, but if we clicked a lime or an orange, get points. So it's kind of like narrowing down. Yeah. Rather than everything being fair game.
How you know?
Cool. So we're going to do explosions because that's fun. So if you go to Assets at the top and go to Import Package, so when you download Unity, you get, not only do you get Unity, you get all of the documentation, all the script reference local onto your machine. So if I'm on the train and have no Wi-Fi, which you have no Wi-Fi's on the trains in the UK, which is quite annoying. And so I was in Finland, I was like, whoa, you have Wi-Fi on the trains, this is awesome.
Wi-Fi on the bleeding train.
Yeah, yeah. Yeah, UK sucks. No. Yeah, so when you download Unity, you get the project. You also get all the docs that are online, are all local. So if you try and open up the docs online, it'll basically like route you to the local file. So you have all the script reference there. So if you're on the train, you want to do a bit of a game jam, or I don't know, or train jam, or whatever it may be, then you can do it. You have all the script reference. But also, it also brings in all these packages. So these packages are kind of like standard assets, like example products, example scripts, example things that our dev team have made to show off a couple of bits and pieces of Unity. And when I started with Unity, I basically went through and had experimented with all of these things. They're quite useful to go in and see how things are made. So what we're going to do is we're going to go down and we're going to go to particles. We're going to import the package of particles. Again, it's going to show you this import package. And it's going to say, do you want all of this fun stuff? Would you like all of this? Yes, I do. And what it will do is it will then import it and it will put it in a little folder called standard assets. It takes a little while. But these are all local to your machine, so you don't have to be online and things like that. Go into standard assets and go into particles once it's downloaded, and you now have dust, fire, smoke, sparkles, water. You've got all these different things that you can play around with that are pre-made, that you can customize yourself and use in your game. So if I go into legacy particles, we have a couple of things. We have sparks. So if I drag and drop sparks into the game, basically, I now have a series of sparks which are being emitted. So these are from a particle emitter, a thing which is emitting a series of particles in a particular way. And what you'll notice in the particle emitter for this object, so once I've brought it in, just dragged and dropped it in, it's got a whole load of stuff I can play with. So probably spend all day just playing with all these different things, but most of them are self-explanatory. So for example, the minimum size and maximum size. So I could say the minimum size of an object is 0.1, maximum is, for example, 1. So it's going to range between 0.1 and 1. I can say velocity, so I could say it goes down. It always goes down, things like that. Basically, you can play around with this and set something like that. So it's more like an explosion type thing. So what I want you to do is I want you to pick one of these particle effects. So I'm going to go with small explosion. And that's playing. And I'm going to set it to be a one shot. So if you select small explosion, drag and drop it into your scene, you can see it previewing in the scene, and you'll be able to play around with these settings. And if you turn off one shot, that would be like a continuous thing. So for example, a candle would be a continuous particle effect happening. If you turn on one shot, it's kind of like going to play it once, then remove itself, play it once. So this is quite useful for our fruit explosion game, because you're going to click on a fruit, it's going to play the explosion, and then it's going to remove. It's not going to click the fruit and then the fruit's forever going to be on fire, or something like that. So yeah, I'm pretty happy with this one shot. Small explosion. Cool. And you can also sort of play around the colours. So I now have it's slightly blue, I think. Yeah, now I have sort of bluey, greeny. Ready, yeah. So now it's kind of a bit more. Starts off bluey, green, and red. So yeah, particle effects are pretty cool. They're kind of like one of those things that you can't really show people. They have to bring them in and experiment and see what they can make for themselves. Which I know is a bit of a cop-out thing of saying, but they really are. They like go through and play around with them how you want them to play around. It's pretty cool that they simulate them in real time as well. So what I want you to do is use one of the standard assets, find an explosion or something like that, make sure one shot parameter is ticked, and then basically tweak it a little bit. So spend like 1 or 2 minutes tweaking it, and then I want you to create a brand new prefab for it. So we have all the standard assets that are preset that we can use later. So perhaps we want some form of smoke trail from the fruit. They're like flaming fruit that's just popped out of, I don't know, something. And when you have your particle explosion that you want to replace for the fruit, set it as a prefab in your fruits folder. So just drag and drop it into the prefab slot, and we have our small explosion. Yeah, particles are pretty cool. So mine kind of like, it's like radioactive and then it sort of burns out. I don't want to eat this fruit. Okay, as well as one shot being turned on, nothing you want to put on is auto destruct. So what auto destruct does is it basically, when the one shot is finished playing, it then removes itself, so it almost like does an auto destroy. So that way you don't have to write some extra code to say remove yourself after 5 seconds, for example. Particle system's already going to do this. Now this is the old particle system, the old particle emitter that you can still use and you can still play around with, but there's a new, better up-to-date one. However, in the standard assets that are in Unity 4 point something, they don't have examples of it. It's all on the asset store, which you have to download from online, and yeah. So yeah, if you go on the asset store, there's lots of different particles that people play around with and things like that. Download and mock up. Oh, if you scroll down, underneath the bit which is particle emitter, it should say auto destruct.
Oh, there it is. I got it. Yeah.
So that's a separate game.
Yeah. Awesome. Cool. And yeah, you can go inside. It's great. You can cast shadows from the particle. Yeah, you can do some lots of pretty cool stuff. Yeah, awesome. So we have our explosion. Has everyone made a prefab out of it? Or cool. So drag and drop it into your prefab folder. So now, along with your fruit of lemons and limes, or your citrus and things, we now have explosions as well. So they go very well together, hand in hand, right? Not really. The jokes don't get any better. I said this earlier on.
Getting darker.
Yeah, it's getting darker, it's getting later, and they're getting a bit worse, if they could already get any worse. So we have our small explosion. So now that we have our small explosion prefab saved, and I'm pretty happy with my radioactive explosion. What I want to do is I want to write some codes to emit it every time we click on the particular thing.
This is exactly the effects the game
No, basically what I did was, if you go to standard assets, you have all your things here. You just drag and drop them into your scene, and they'll all be pre-made. That's a game object, which has a transform and things like that, but it already has emitters and textures and things already on top of it. And then I made a prefab of my own individual thing, so I can go back in and use small explosion if I want to use it for something else and stuff like that. Cool. So we're going to add 2 lines of code, and then we'll have explosions happening, which is quite exciting. So now that we have our prefab of explosion, we need to basically instantiate it wherever we have clicked the fruit, or wherever our hit point is of our invisible raycast being sent out. So I'm going to create a game object called, with an uppercase G, called explosion. Then inside this if statement where I click on it, it's going to destroy the object, it's going to play the audio, and now it's going to do instantiate explosion at hit.point, so at the point of the hit, and then it doesn't matter what the rotation is because it's an explosion. As a game object. So you notice I'm not assigning it to a variable because I'm not going to be using it for long. I don't need to go into the particles and basically say, now recolor yourself, or now change your name, or things like that. I'm not caching it for later use. I'm just instantiating it like normal as a game object. I don't need to worry about any specifics. Cool. Ah, we have a problem. Has everyone else got an error, or is it just... Yep. Okay, if you take out that as game object bit, that's fine. I think you only need the... Yeah, you only need the as game object bit if you're caching it. So yeah, take that bit out, just having box standard instantiate. What you should have now, after you've attached the particle explosion in, so drag and drop it into your particle explosion slot. What you should be able to do now is dodgy fruit. It's the Hulk's breakfast. I'm fairly terrible at my own game. So you could do all sorts of things with the particle. You could, for example, have little drops of juice come out and stuff, so you're squashing the fruit. Yeah, you could do all sorts of things, which is quite cool. So I'm currently using one particle effect for all, but what you could do is you could say, if I've clicked a line, use a yellow particle effect, or recolor particles to be yellow and things like that. Which we're going to be doing that in a second. We're going to, I mean a lemon, We're going to find out what we've clicked and then do something based on what we've clicked. Awesome. So it's nearly 4. So what we're going to do is let's get a point thing going on in the corner and do points based on if you click. So which one should we do? Lime, lemon, or oranges? So you get points. Limes, cool. Everyone always picks limes. Just people in Finland just love eating limes, or oranges? There's a debate now going on and what fruit we should navigate. Cool. So I'm going to raise a problem. So what could be problematic with determining on what we're clicking? So if we're sending out our raycast to a particular object, so for example this is returning the object and its name of projector, what could be a problem with all these objects that we're instantiating? No, they all have clone on the end. So basically, any object that's instantiated or duplicated has clone automatically added at the end, so you know what is would be the master object and what would be the clones. I think there should be a little tick box to say I don't want them to all be named clone, things like this. So what we have to do is we could write some messy code and say if the game object's name is orange_half clone, so on and so forth. We could write some messy code like that. However, we're not going to. What we're going to do is we're going to rename the objects as they're created to what they actually are and get rid of the clone bit, which is fairly straightforward. And this is a little trick as well. There's all these little tricks going on. So let's go to the fruit spawner, so the thing that creates the fruit and flings it up in the air. Cool, so now that we have the fruit spawner, what we want to do is, after we create the fruit, as we cache the fruit, and it's now called created fruit, what we want to do is we then want to rename it. So we're basically going to say, and this is a neat little trick, so we're going to say created fruit dot name equals fruits array random fruit int dot name. So what we're doing is we're saying that object that's created that's got whatever clone, actually we don't like that. We're going to go to the fruits array, go to that number that was picked, get the name of that item in that array, and then pass it in. So it's now not going to have clone. It's got a name, creating it and naming it, and then we're renaming it back again. Yeah, but now they're all called lemon, orange, lemon underscore half. We don't have to write clone on the end, which can potentially get a bit confusing. So after you wrote that code, run the game, make sure that it does actually say name on the end, and yeah, everything will be groovy. Here we go, lemon, lime, orange, lemon underscore half. Yeah, all these different fruits are being thrown up, and it looks neater, basically. Cool, so people really love this game. What's it clicking? I apologise. Alright, okay. Cool, so what we're going to do now is we're going to narrow things down. So currently our raycast detects if we click whatever we want, and basically says whatever we click, destroy it, play audio. But we want to narrow it down. So like in Fruit Ninja, for example, you click a bomb, other event happens, or you click some fruit and something happens. We're going to do that. So you said lime. Cool, so we're going to basically narrow it down. You get points for a lime. If you don't, no explosion, you actually lose points and gradually get worse over time. So what we can do now is I'm going to select these 3 lines and tab them all up. So the destroy, the audio, and the particles, we're going to tab up. And inside this if statement, we're going to write another thing and narrow it down. So we're going to say if hit.collider.gameObject.name equals line, or hit.collider.gameObject.name equals lime underscore half. And wrap those in that. You all know how if statements work. So now what's going to happen is it's only going to run that stuff if it's in that particular bit. If it doesn't, then it doesn't. So what else that we want to do is we want some form of points. So we need to set up 2 variables at the top. So the first variable that we want is going to be current score. So this is going to be an integer that's just going to store what level we're on, or how many points that we've garnered. The other one is going to be public GUI text score display. So what's the point of showing how many points our player gets if we can't actually show to them what points they've got? So what we're going to do is inside this if statement, if we click a line, then we're going to destroy it, which is cool. You've clicked the right thing. Audio source, yep, we've played the splat sound effect, create the explosion, and we're going to go to the current score and plus a value of points. So how many points do you reckon you should get if you click a line? You said 5, so cool. So 5. And what we're going to do is we're going to write an else statement, and we don't need to bother checking if we've clicked an orange and things like that. And we're just going to go current score minus equals, I'm going to be brutal and say 10. Yes, we're really good. Cool. So it should be adding score and taking the score away. Now, as we've made current score, I've added that other variable. We'll be using that in a second. As we've added current score to this particular thing, we're going to be able to see it because it's public in the inspector. So before we do some form of GUI display or some form of text in the corner or some form of label to say how many points you've got, we can actually see that it's working before we then do the next steps. So whenever I do anything, I do like little baby steps to make sure it's all working, as opposed to one of my friends who writes like 1,000 lines of code, then sees if all that works, and then error central happens because none of it works. So what we're going to do now is click on the camera. We've got our current score value here. We're going to play the game. Yeah, I just clicked on orange and then I've just lost points, whereas I clicked the lime and I've gained 5 points. You have to be very careful. Cool. So now that we have all points, let's display the points in the corner. So we're only going to do like a little bit of GUI stuff. I'm not going to go into it because it's a whole other area and spend like days basically doing whole GUI elements and sliders and all sorts of fun stuff like that. So we're just going to put a little label in the corner. In Unity, there's a couple of ways you can do GUI. So one way would be to just use very static labels or textures and things and just position them somewhere on the screen with a certain offset and things like this, which is what we're going to do. So that's one way. Another way is to do it all by code. So you can basically draw out your GUI area and things like that. But that method isn't particularly optimized for mobile, so it runs like twice every frame, I think. And yeah, it's not as optimized. Or you could use a third-party plugin like NGUI or EasyGUI and things like that, where they're basically optimized for mobile. But we're working on our own GUI, brand new GUI system, which has been in development for a long, long, long time. But it's getting towards the nice bit. Cool. So one way, we're going to do the very quick way. So rather than scripting out the whole GUI interface, just to display a number in the corner or number of lines splatted or whatever it is. So we're going to go game object, create other, and we're going to use GUI text. So GUI text is just a standard label which renders in the camera on top of all the 3D elements. GUI text is just a standard texture which is rendered on top of all the 3D elements. 3D text is if you want to place some form of text somewhere in the world. So for example, on a digital clock, you could have some 3D text, and then as it moves around, you just make it part of it. You could do all those sorts of things. So in this case, we're going to use GUI text. Now, the GUI text is within our hierarchy, but you can't see it in our scene. It's nowhere to be seen in our scene. Yeah. And if you focus on it, it just goes to the origin point of 0, 0, 0. Or it looks like it does. The way to see GUI text is to actually go to your game view. Okay, cool. Go to your game view and you can see what it looks like. And this is where you have to change things. So rather than the scene view where you have all these nice handles and you can zoom around, the game view is basically showing the end overlay with this GUI text. So if you go to the game view, select the GUI text, you'll be able to change all these properties about it. So there's a couple of things about these properties that are different from in the scene. So in the scene, if I select, for example, the directional light, its position is going to be X, Y, Z coordinates within that world, and the same with rotation and things like that. GUI text operates in a slightly different way. It basically says 0.5, 0.5, and it's basically depending on the ratio of the screen. So 0.5 and 0.5 means it's sitting directly in the middle of the screen, but its anchor and alignment are the upper left. So if I set the anchor to, for example, be middle center, and the alignment to be center, for example, that's now going to be sitting in the middle of the screen, no matter how big the screen is or whereabouts it is. GUI text is always going to be set there. So it's better to think of these as rather a percentage as opposed to 0.5. So that should really be like 50, and the other one should, and the Y should be 50 to mean it's sitting in the corner, sitting in the middle. So what we want to do is we want to sit it in the top left-hand corner here. So I'm going to set its anchor to be middle left. So that means it's going to be sitting from this sort of visual point here. And we're going to say X 0.1. Or actually, 0.1 or 0.05 or something like that, just so that it's sitting on the left-hand side. And then from here, we want to go 0.9. or 0.95. Something so it's just sitting in that corner. And what you'll notice is if you resize the game view, basically it's always going to be anchored to that particular point in the top right left hand corner. So it's kind of a bit of a difficult way of thinking about it. I've shown some people GUI text and they instantly input, okay, I'm going to set the coordinates to be 500 by 300. But then, you know, obviously that's not going to make sense because in this sense it's 0 to 1, 0 to 1, and Z just holds the depth. So if you want text in front of textures or vice versa. I don't think rotation works either, does it? No. Yeah. It ignores rotate. I think it ignores scale as well. Yeah, so that should be absolutely massive. Yeah, it ignores that as well. So it kind of operates on its own sort of lone wolf style thing as opposed to all the other things. So with the GUI text component underneath here, we can type in some text. So for example, lemons squashed. However, that's going to be completely pointless because we're going to be changing that in code. We're basically saying in code update what the text says. We can set pixel offset, line spacing, all these other things. The font is currently Arial, which is fairly boring. So what we're going to do is we're going to click the target, and we'll notice I've given you Clavica, which is like the font that Unity uses for everything. I mean all the branding and things like that on the website. So basically you can tag Clavica so it looks a bit more nice and change the colour. So what is it, limes that we're squashing? So we can change it to a nice lime green and go limes splattered. And we can change the font size as well. So yeah, basically make it pretty big. Awesome, cool. So we've all got a very simple thing in the top left-hand corner that says this. We're going to output a very simple string to. And that's probably going to be the last thing that we do today. I think we've kind of run out of time. We'll do Iron Man stuff tomorrow and everything else. That's cool. So now that we have our GUI text output to, if we go to the camera, which if you remember we actually have that variable in, of score display, drag and drop GUI text into that little slot, so we have it in there. So now that we dragged and dropped fruit from our projects that's stored for a rainy day and small explosions and things, we're actually tagging the GUI text that we've got within our scene, and we can then output a particular message to it. So has everyone dragged and dropped it in there? Cool. So what we can do is we could either update what this says every single time that we get a new score, or you can stick it in update and have it constantly updating. Let's do the bit more optimized way. So what we're going to do is we're going to say score display dot text, because we want to access the text, and we're going to do limes. It's called fruit splat, so limes splatted, and then we're going to just add whatever the current score is. So as soon as we click lime, it's going to destroy it, play audio source, create explosion, adds points, updates the text. Cool. What we also want to do is as we lose points, we want it to update the text as well. So let's just do that there. So we put those in there so we're not updating it every single frame. Even if we've not clicked anything for like 5 minutes, it's going to be updating every frame if we just left it in update. It's only updating when we actually update that value, which is, I guess, a bit better. I'm on -10. So yeah, very simple game. I should have brought in like a little sound when you hit like wrong fruit, or perhaps you should also destroy the wrong fruit but you get a lower score. I don't know. Like limes, for example, give you more points. Well, lime splattered doesn't actually make any sense because I haven't splattered -20 limes. So it might be a bit better if I set that to be like points or score. Cool. Wicked. So yeah, we've basically put together a very, very simple game. So yeah, we've covered lots of bits and pieces. Some of you probably already knew some of that, like scripting wise. Some of you might not have known it, but I guess you all know it now, so that's cool. And yeah, and I think 4 o'clock was my cut-off, so I'm 7 minutes over. Sorry, you guys, 7 minutes. Yeah. So what we're going to be doing is, if you guys are feeling adventurous, so like after dinner, what we have planned next, you want to go a bit further and experiment with it and things like that, and do other bits and pieces. Perhaps put in different types of explosions depending on what you click and things like that. Basically, just expand it how you want. What we're going to be doing tomorrow is basically focusing on building it to particular platforms. So now that we've built this thing together, we're then going to push it to platforms. So we're going to build it to a Windows 8 app and then have different types of tiles based on how big they are in the display. We're going to do some mobile inputs like fly a spaceship around and shoot lasers from the spaceship, build that to a Windows device, and then get the Windows device to vibrate every time you fire a missile and things like that, and access things from there. If we have time, we'll go on to do Iron Man stuff, which is cool. So you have animate Iron Man running around and sprite sheets and stuff. So yeah, lots of stuff to do tomorrow. So everyone get some rest, basically. I probably will as well. Cool.